Hello and welcome. In this video, we're going to be talking about graphing linear inequalities. So when graphing, just cross out that word one because that doesn't make sense. When graphing linear inequalities, we have some steps to follow. The first step, I'm going to decide if the line will be solid or dotted. If I have the symbols less than or greater than, I will draw a dotted line to represent my linear inequality. When I draw a dotted line, what that means is that all ordered pairs on the line are not solutions. They are not part of the solution set for that linear inequality. So you might be able to imagine that if that's the dotted line, when I have a less than or equal to or a greater than or equal to sign, this is when I would draw a solid line. And when I have a solid line, all ordered pairs on the line are solutions. So these points along a line are part of the solution set. As with graphing linear equations, you should use the most efficient method to graph. That might be the slope-intercept method. You might use the x and y intercepts if this equation is written in standard form. You might even use a table of values. Try to use a ruler for precision if you can. The final step of graphing a linear inequality is to shade appropriately. So when I'm doing that, we're going to try to use a test point. So we're going to choose a point that is on the coordinate plane, that is not on the line I drew, either the dotted or the solid line. If you can, 0, 0 is always the best test point. After I substitute in 0 for x and 0 for y into an inequality, if the resulting statement is true, then the test point is part of the solution. If the resulting statement is false, the test point is not part of the solution. This will make a lot more sense once we put this into action. So let's first go down to number 1, graph each linear inequality. Then list 3 solutions to each inequality. A solution is an ordered pair. So just remember, with linear inequalities and linear equations, solutions are ordered pairs. So in this case, I have y is less than 1. I'm going to ask myself, is the line dotted or solid? Well, this is a less than symbol, so I need a dotted line. I do like to use the table of value method with my y equals or y less than and my x equations, because that really just helps me remember, do I have a vertical or a horizontal line? In this case, the value of y is always going to be 1. So if I just choose 2 points, let's have x equal 3 and x equal negative 3. Now let's plot those 2 points. If x equals 3, 1, 2, 3, y equals 1. If x equals negative 3, 1, 2, 3, y equals 1. So you can see, if I just add 0, y equals 1, that I'm forming a horizontal dotted line. So I'm going to dot along this line, and I still will add my arrows. Now I need to know, am I going to be shading above or below the line? So I am going to use this test point of 0, 0. My test point is 0, 0. So remember, 0 is the value for x and 0 is the value for y. Well, in this equation, y is less than 1. I don't have an x, I just have y. So is 0 less than 1? It is true. So the test point is shaded. I'm going to shade where the test point is. I'm going to just use my red pen here and shade all here. And so what this tells me is in the linear inequality, y is less than 1, It represents a dotted line at y equals 1. All of the points along this line are not solutions, but all of the points down here infinitely are solutions. So let's pick some points. Well, of course, the test point we know works. And this point works too. That's at 1, 2, negative 2. And this point works too. Negative 2, negative 2. There are infinite possibilities that you can choose. Let's take a look at number 2. Y is greater than negative 3x plus 4. This looks like a y equals mx plus b format, so I'm going to use the slope-intercept method to graph. This is a greater than symbol, so it is going to be dotted. Y equals mx plus b. I know that my y-intercept equals 4. The y-intercept is the value of x, of y when x equals 0. So I have a point at 0, 4. And that's where my line will start. 1, 2, 3, 4. Now I know my slope is negative 3. Well, I need a numerator and a denominator because slope is the change in y over the change in x. So far, I just have a change in y. Well, with any whole number, I can put a 1 in the denominator and not change the value. This says to me that I'm going to go down 3 because it's negative and right 1 because the denominator is positive. So I go 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Do you need to do all these points? No, but I figured I might as well. I'm going to dot in between, add an arrow, and now I've got my dotted line that represents y is greater than negative 3x plus 4. Just a side note, if you look here, this is a negative slope from left to right. You can see that I've drawn a negatively sloped line. Last step is to think of a test point. Remember, I always need to choose a test point that is not on the line. 0, 0 is not on the line. So I'm going to use 0, 0. And I'm going to substitute 0, 0 into the equation. So y and x are 0, so 0 is less than negative 3 times 0 plus 4. 0 is less than, I'll multiply first. Negative 3 times 0 is 0, so that goes away. And I've got 4. And I have to ask myself, is 0 greater than 4? Well, no, false. So guess what? The test point is not shaded. So I'm not going to shade the 0, 0. Instead, I will shade above over here. So all 0, 0 is no longer, it was a solution here. It is not a solution in this particular inequality, nor are any of these points along the line, but this point is a solution. That's at 1, 2, 1. This point is a solution. That's at 1, 2, 3, 4, negative 1, 2, 3. And this point is a solution. That's at 1, 2, 1, 2, 3, 4. So it was this case, lots of different possibilities of possible solutions. Just as a note, linear equalities have many solutions. Choose the obvious, in other words, points that are definitely in the shaded region. And that's, you can see with my points, is what I did. Let's go on to page 61. We're going to look at number 4. And in this case, I have an equation, 2x minus 4 is greater than or equal to y. That is in standard form, so I'm going to use the slope-intercept method of graphing. First thing I want to do, though, am I going to have a solid or a dotted line? This is a solid line because I have a greater than or equal to symbol. Let's find my x and y intercept. The y-intercept is the value of y when x equals 0. So if x equals 0, I have 2 times 0 minus y is greater than or equal to 4, negative y. And actually, I'm just going to use equal signs when I'm finding the intercepts with inequalities. Just keep it a little simpler because I'm just looking for an absolute solution. Okay, this is negative y, so y is not by itself. Just adjust the focus there. So I'll divide by -1, divide by -1, and y equals -4. So when x is 0, y is -4. 1, 2, 3, 4. My y-intercept, excuse me, I just found my y-intercept. My x-intercept is the value of x when y equals 0. So if y equals 0, I have 2x minus 0 equals 4. 2x equals 4, divide by 2, and x equals 2. So my next point is at 2, 0. 1, 2, 0. And I have a solid line, so it's going to be solid. Not amazing on the line front, but not too bad. I don't have a ruler with me. And now I need to figure out my shading. So I'm going to think about my test point. Remember, if you can use 0, 0, and I can because it's not on the line, use 0, 0. So I'm going to substitute 0 right in for x and y. 2 times 0 minus 0 is greater than or equal to 4. 0 minus 0 is greater than or equal to 4. Is 0 greater than or equal to 4? False. So the test point is not in the solution. I'm going to be shading this way. Something to note, because this is a solid line, all the points on this line are a part of the solution. So both my intercepts are solutions, so possible solutions, 0, -4, and 2, 0, and I'll just pick this one right here at 1, 2, 3, -1. Excuse me, 1. Oh my goodness, 1, 2, 3, -1. I really wanted to write that 1. Alrighty. Again, lots of solutions you could choose. I simply chose to choose the ones I had already found and another one. Number 4, slope. This is in standard form. I am going to use the y-intercept, x-intercept. So the y-intercept is the value of y when x equals 0. If x equals 0, 1/4 times 0 is 0. So I am left with 1/2 y equals 1. To get rid of any fraction, I multiply by the reciprocal. And y equals 1 times 2 over 1. Excuse the focus. 1 times 2 over 1 divided by 1, y equals 2. So my first point is at 0, 2. The x-intercept is the value of x when y equals 0. So if I put 0 in for y, I'm left with 1/4 x equals 1. Going to multiply by the reciprocal because I've got a fraction. And I'm left with x equals 1 times 4 divided by 1, which is 4. So my other intercept point is 4, 0. 1, 2, 3, 4. Now, I forgot to determine dotted or solid line. This is a dotted line because I have the less than symbol. Do, 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 do. Alrighty. There we go. I've got my line all drawn up. Last thing to do is a test point. Happily, I can use 0, 0. So x is 0 and y is 0. Well, 1/4 times 0 is 0. Plus 1/2 times 0 is 0. Is that less than 1? True. So 0, 0 is part of the shaded region, and I can shade below it right here. Because this is a dotted line, the intercepts are not solutions. However, 0, 0, my test point, is a solution. I also can use 1, -1. And let's go for this one, -1, 1. Okay, that is all for this video. Hope it was helpful, and I'll see you next time.